So we reviewed some various protocols and attacks, and now we'll talk about using network devices in a secure way. So talking about secure network configurations. And it's one of the first things we talk about is rule and role-based network device configuration. So rule-based management approach basically is when we talk about using rules in a device to make a decision as to what to do with traffic on a network. So most of these devices that we've talked about, they have to do something on the network, right? They have to pass traffic from point A to point B, and they're making decisions to do that, to do whatever it is the thing that they're doing, whether it's a firewall, a router, a switch, all of these various devices that we've talked about. So basically, the technical rules define the device security, network management, and port security. For example, configuring a firewall to conform to procedural rules. So we can have rules in our devices. One good example of rules that we talk about is routing rules, right? So routing rules are rules that define how a router is going to pass traffic through our network, and we can make those rules enforce some of our policies and enforce the way we want our network to work and some of the boundaries that we draw around our networks and so forth. So a secure router configuration, as we talked about before, routers operate at network layer 3. They forward packets across computer networks, which we've talked about before. Hopefully you've seen this in other classes as well. So routers can perform a very specific security function, and they are configured to filter out specific types of network traffic. There's not a lot they can do beyond that, so we can't rely on routers. In the old days, routers were also kind of our firewalls in a way, but we try not to rely on routers to do that anymore. So here are some things that we can do with a router. We can create our network design. Using our routers, we can implement that design. We want to make sure we use a meaningful name on the router so we know which one we're configuring and we know what it's what it's for, what its purpose is. We want to secure all the ports, including management ports and auxiliary ports, console ports, so we can make sure somebody can't jack into that router and make configuration changes. And we want to make sure we have a very strong administrator password. If somebody were to brute force and get into that firewall, if they're able to guess the password, there's a lot of damage somebody could do on your network if they're able to access the routers. All right, and we want to be able to make changes, or we should prefer to make changes from the console and not from a remote location. Just in general, it's better to do it from the console port, although I think most of us end up using remote connections anyway. We usually SSH into firewalls and routers and things of that nature. So one of the things that routers can do for us is flood guard. This can help with denial of service and distributed denial of service attacks. So a SYN flood attack is basically where we're trying to initiate many sections with a device so that it attempts to open up connections to another device, or many devices, I should say. So we'll open up connections to many devices, but have the return address going to a single node in order to flood that system. And there are both nefarious reasons that happens, but also technical reasons that can happen. In either case, we can use flood guard controls or flood guard to control a device's tolerance for unanswered service requests. So we can it puts basically a damper on all of these unacknowledged SYN packets that are floating around the network, and it prevents them from going over and over again until you have a denial of service attack. So you can set the maximum number of developing connections that are going through the router, and again, you can do this in firewalls as well. But it's basically a feature that's normally on firewalls, but intrusion detection systems and intrusion prevention systems can also have this feature. And again, a lot of times IDSs and IPSs are part of a firewall as a unified device, which we talked about before. So again, it can protect against DOS and distributed denial of service SYN flood attacks. We want to monitor our devices. So all of these different devices that I talked about, they all write logs. They record all of the events that occur on that device. So security logs can reveal types of attacks that are being directed at network. We also have access logs, which are part of the security logs. So we have access logs that tells you when somebody accessed the system. You have audit logs to record how the configuration changes are happening or what configurations. Event logs are when things happen. A packet is dropped, a packet is denied, or something like that. That all goes in the event logs. Almost all of these network devices that we've talked about all have logs. And the logs are probably one of the most important places we can go to when there's an incident. So if something happens, one of the few places we can go to kind of reconstruct what happens is those log files. I'm sure all of you are familiar with the term black box when on airplanes. When an airplane crashes, everyone asks, where is the black box? And they're always looking for that black box because the black box is the only thing that has a record of exactly what was happening on that airplane when the airplane crashed. Without the black box, it's very difficult for people to piece together exactly what caused the crash. There's been a few high-profile crashes in recent memory. Malaysia Airlines, I think it was 370 that just disappeared somewhere in the Pacific. They can't find the black box. They spend a tremendous amount of money, time, and effort to try to find that black box because it's the only thing that can answer the question as to what happened to that airplane. Likewise, if we have an IT security incident, the only thing that's going to answer our question as to what happened is going to be these log files. It's the black box of IT security that tells us exactly what happened. So it's important to not only have these log files configured and have them being saved, but also to have them backed up somewhere where you can access those if a system crashes or if something bad happens, you'll be able to go and get that information. And a lot of IDSs and intrusion prevention systems, they use those logs. Those logs are what gives you a heuristic view of what's happening on the entire network. So logging is very important. Firewall logs might log the IP address that's being rejected and dropped. Any probes to ports that have no application services running on them, which would tell you that somebody's trying to attack your firewall. Source routed packets, suspicious outbound connections, so at things that are coming from inside the network, unsuccessful logins to the firewall itself. So all of these things can be logged, and again, it's important to save all this stuff and to have all this. So we want to make a decision as to how long we're going to keep these logs, how far back we're going to go, so that when there is an incident, we can go back in time. And sometimes it's easy to say, well, we should only keep 30 days of logs because what are the odds that we're going to have a problem that we have to go back more than 30 days? But sometimes you don't find out about an incident until long after that incident's occurred. So it's important to think about that, and depending on your level of exposure and how much security you need in your network to decide how long to keep these logs. So a log analyzer, so one of the problems with log management is you've got lots of different logs, you have to store them, and then you have to analyze them. You have to look at those logs, which can be kind of like finding a needle in a haystack. So we have all these different devices that are all generating logs all over the network. There's a very large volume of data that can be produced in these log files, especially if they're saving every packet. I've had some network devices that you can configure it to save every single packet, and that's a tremendous amount of data to save, which is a little overkill, but theoretically, there might be a reason someone would do that. You have different log formats, but all of this stuff can be aggregated into one place, and that's a centralized log analyzer. So you can have these logging utilities that can run from a centralized location, and it will log all of the activity on the network by aggregating all the logs from all these different devices. And again, we talked about that with intrusion detection and prevention systems, which can also do that log aggregation. And here's a screenshot of one such utility where we can see activity sort of heuristically across the network in this graphic format, which would be very difficult to do if we had to do this manually. If we had to go through all of these devices and try to read all these logs, it's very difficult to sort of put these different log entries together to see what's happening overall throughout the network. One thing I should mention, it's important, and I don't think your book mentions this, that if you are going to use these logging utilities, you really have to make sure that the times are correct across all these different logs. If you have one device that is set to Central Standard Time and another one Eastern Standard Time, and the log system doesn't know that, everything's going to be offset by an hour. Which could be a problem because it's not going to have context between these different devices. A lot of times when we're looking at these logs, it's helpful to know temporally when they occur in relation to other devices. So it is important to make sure you have the timing set correct when you're doing this log analysis. So network designs, there's several network design management principles that we can follow to ensure security and viability of network are maintained. We can have network separation to prevent bridging. So in other words, prevent people from being able to get from one network to another. Loop protection, as well as VLAN management. So network separation is when we can separate secure parts of the network from unsecure parts. You can physically separate users by connecting them to different switches and routers, which would prevent bridging. So it would prevent them from bridging from one network to another using the ports or using wired connections. So it can prevent reconfiguring a device from allowing that connection to occur. So in other words, a user might be able to just change their IP address to the protected network. If they know the protected network is 10.0.0. something would get them on the protected network, but they have a 192.168 address. They can't just change that address because they are physically separated from that network. And routers and firewalls and things like that can detect that type of thing, which we talk about in network security classes. A switching loop causes a broadcast storm. This used to be a common problem in networks, but most devices now have loop protection, among other things, that keep broadcast storms from happening. When it happens, it can cripple your network. In some cases, in a matter of seconds, until your network basically is unusable until you reboot everything, and stop that broadcast storm. The problem is a broadcast storm can affect all the devices. They're all doing this broadcast storm, and it just keeps compounding. And it's a logarithmic thing. It's it increases at a substantial scale, so it increases very quickly. So loop protection prevents those broadcast storms. Spanning tree algorithm, or STA, uses the 802.1d standard to determine that the switch has multiple ways to communicate and host, and then determine the best path while blocking out other paths, which can help prevent the loops. So VLAN management. We've talked about VLANs very briefly before, but basically you can use VLANs in addition to separate devices. So a VLAN allows you to have a virtually separated device with ports that are assigned to one LAN or another, and users will not be able to just simply set their IP address when they're in one VLAN to a different VLAN. It will not work. It will not allow that traffic to pass from one VLAN to the other. And by the way, one of the advantages of a VLAN is if you have users that are scattered throughout the organization. So let's say you've got different employees sort of all peppered in the same building, throughout the building. They're not contiguously in one place. It would be difficult to use physical devices to maintain that separation between networks. However, a VLAN would allow you to do that. You could, anytime you need to, you could switch a port to a different VLAN. So the general principle is you can configure empty switch ports to connect to an unused VLAN, so somebody can't jack in and just start accessing the network. You can change any default VLAN names. You can configure the ports on the switch to pass tagged VLAN packets to explicitly forward specific tags. You can configure VLANs that the public devices are not on a private VLAN, forcing users to have to access that VLAN, and so forth. As far as port security, this deals with ports on the devices themselves. So turning off ports that are not required on a network. This is an often overlooked security technique because it's rather tedious to make sure that all of the ports that are not used are not enabled. The problem is if you disable a port that is used, then that's obviously a problem. So a lot of administrators are hesitant to do that because of the concern that they're going to block a port that's actually in use. Sometimes it's kind of hard to tell, but so a switch without port security allows the attacker to connect to unused ports and attack the network. So all ports should be secured before a switch is deployed. In other words, we know exactly which ports are going to be used, and we make sure that only those ports are enabled so that somebody can't take advantage of ports that are not being used. This is a common attack in many offices where you've got network interfaces that are not protected, that somebody can come in with a laptop and jack into any port and be able to access the network. I've worked for buildings and for companies where we have those ports outside the building. I work a lot in healthcare, and we have Ethernet ports sometimes that are outside the building for these mobile trucks that come in to do mammography or CAT scans and MRIs and things like that. And sometimes they'll forget to lock up those ports outside. And we've had cases where people were able to jack in outside the building and access the hospital's network. So again, it is important to make sure that you disable those ports when they're not used. So another technique is MAC limiting and filtering. Basically, in addition to disabling unused ports, you can also disable unused interfaces, turn off ports that are not required. Oops, I already had that page. But anyway, so MAC filtering and limiting. Again, we can. I don't have the right words on this slide, but MAC filtering rather is where you can set up specific MAC addresses that can access a device. So you can put in specific MAC addresses so somebody can't. If somebody does jack into your network, they won't be able to use the network because they won't have the right MAC address. This is not a foolproof method, and as you saw in the labs, you can very easily change your MAC address to a valid MAC address on the network. So if an attacker does discover a MAC address that's valid, they can change to that MAC address to access devices on the network. So it's important not to rely solely on something like this, but you can use MAC filtering and limiting. IEEE 802.1x is port security. So this is the highest degree of port security. Rather than simply relying on filtering, this includes authentication. So users must authenticate to the port in order to use the network. Many of you who are on site at Drexel, so if you're a student that is periodically on campus, you may have noticed that you have to authenticate to the wireless access points. You can't simply connect. One thing you may also notice is that you do not get an IP address on the wireless network. You're not actually connected until you authenticate. So your computer connects to the wireless access point. Using 802.1x, you have a challenge response that asks you to put in a username and password. So it's not like WEP or WPA2, which we're going to talk about in the next unit, where you put in a static security key. You're putting in your actual user authentication or user credentials to authenticate to that network, to that access control point, or access point rather. So it implements port-based authentication, and it blocks all traffic on a port-by-port basis until the client is authenticated. So that means that when you jack into that network or connect to that network, you cannot access the network until you've authenticated to that port. This works in both wired and wireless networks, so it can be utilized for both. Some people say that it's a little overkill to use 802.1x on a wired network. I would disagree because of some of the attacks I talked about before, where an attacker may come into the network and jack into a port and try to get an IP address without authenticating to the network. So it's a good protocol. It's a good strategy for us to try to protect our network. So this is just an example of how the 802.1x process works. One thing that's important to note about 802.1x is that you are not connected to the network until after authentication happens. So the access control, or the access point rather, or the network switch that you're jacking into will first present a window asking for your credentials. But this happens again before you even get an IP address on the network. So first you provide the credentials, then it goes out and authenticates you on the back end, and then it comes back and it gives you access to the network after you've been successfully authenticated. So you do not get an IP address until you've been authenticated, and I think that's an important concept to take away from 802.1x and understand about 802.1x. So applications and platforms, several relatively new network applications and platforms require special security considerations, such as IP telephony and virtualization, as well as cloud computing. So I'll talk about virtualization and cloud computing in the next video, but IP telephony, obviously, that's I don't want to say that's a new technology, but it's very quickly converged with the technologies that we maintain with IT security. So, years ago, everybody had telephone lines that were separate from our IT infrastructure. But today, telephones are actually on our IT infrastructure. They're using internet protocol. So they are connecting through the internet or through our local area networks. So we have to be concerned with that traffic, and we have to be concerned with that service. Obviously, if telephone service goes down, most businesses are severely affected by that kind of outage. So it's something that we have to be concerned with and we have to understand. So a lot of digital technology, a shift rather in digital technology is underway, where everything is converging on IP, including voice and video traffic and things like that. So IP telephony is using data-based IP network to add digital voice clients and new voice applications into the IP network. So some of the advantages: you have a cost savings. You no longer have to maintain multiple different types of networks. You have one type of network, one type of technology that you have to maintain, and it works for all these different devices. It's a single network for all applications, and applications can be developed more quickly with fewer resources because it's the shared technology, these shared protocols that we have, and it reduces wired infrastructure requirements. In other words, we don't have to run phone lines, and it reduces regulatory requirements. Because we no longer have to do what the phone company wants us to do, and can increase user productivity. For example, a lot of IP phones let you take it home at night, and now you have your office phone the next day at your house, so you don't have to worry about using your cell phone versus the office phone and so forth. Because they use IP networks, IP telephony has vulnerabilities and is subject to attacks. So first is operating systems. A lot of these phones have operating systems, like some kind of embedded form of Windows or an embedded Linux, more likely. So all of the vulnerabilities that come along with those operating systems we have to worry about for these telephony devices as well. And one of the problems is, in many cases we're not aware of the operating system. It's kind of hidden from us, and there may be vulnerabilities in that operating system that we don't even know about that have to be patched or that we have to harden against. And again, sometimes we're not even aware that those are there. A voice over IP protocol could also be a vulnerability. Many of the common protocols do not provide adequate call party authentication or end-to-end integrity protection, confidentiality. In other words, they may not have encryption baked into them that enforce all of these things that we've talked about for IT security. So again, there might be a lack of encryption. Network acknowledgement, so attackers can flood voice over IP targets with denial of service type attacks. They can degrade service, flood the network and so forth. Just the same thing we can do with normal attacks. And then we have spam. So because the telephony is over the internet, there might be a way to use the SIP address or something like that to send spam phone calls, although it seems like we have that problem in just about every medium. Somebody's trying to sell us something over the phone or internet or email or what have you. So that problem is certainly not going away. In the next video, I'm going to discuss virtualization.